Welcome, medical diagnostics pioneers, to the final episode of our machine learning course. I'm excited to guide you through this episode, where we'll tackle a classification task using a vital dataset and a powerful explainability tool. I'm working in Google Colab, walking you through each step clearly so you can follow along as we classify heart disease diagnoses. Let's begin by setting up our environment and gathering our tools for this life-saving analysis. I start by installing the Interpret library in Colab with the command pip3 install interpret. This library will enable us to use ShapTree for explainable AI, helping us understand our model's decisions. Next, I import the necessary tools. NumPy for numerical operations, Pandas for data manipulation, and Sklearn's train test split to split our data, decision tree classifier for our model, and accuracy score and classification report to evaluate performance. From Interpret, I import ShapTree from the Graybox module, our tool for local explanations, along with the show function to display results. I set up inline visualizations with set visualize provider and inline provider, ensuring our plots render directly in Colab. I also set a random seed to 42 using NumPy's random seed for reproducibility. With our tools ready, let's load the data. I load the heart disease dataset from the UCI repository using Pandas read CSV function, fetching it from the provided URL. I define the column names based on the dataset description: age, sex, CP for chest pain type, TRESP for resting blood pressure, COL for cholesterol, FBS for fasting blood sugar, RESTEC for resting ECG results, THALF for maximum heart rate, XAI for exercise-induced angina, OLPEAK for ST depression, SLOPE for the slope of the ST segment, CA for number of major vessels, THAL for thalassemia, and target for heart disease presence. The dataset uses? For missing values, which I handle with the NA values parameter. I convert the target to binary, 0 for no heart disease, 1 for heart disease present, by mapping all non-zero values to 1 and drop rows with missing values, mostly in CA and THAL. I print the first few rows. The first row shows age 63.0, sex 1.0, male, CP 1.0, TRESPS 145.0, COL 233.0, THALC 150.0, CA 0.0, THAL 6.0, and target 0. No heart disease. The next row has age 67.0, sex 1.0, CP 4.0, THALC 108.0, CA 3.0, THAL 3.0, and target 1, heart disease present. This dataset includes 297 samples after dropping missing values, with 13 features, making it a binary classification task. Let's prepare the data. I split the dataset into features and target X includes all columns except the target, the 13 features, and Y is the target, 0 or 1 for no heart disease or heart disease. I use train test split to allocate 20% for testing and 80% for training, with random state 42 giving us 237 training samples and 60 test samples, 36 no heart disease and 24 heart disease cases in the test set. The features are numeric, and after dropping missing values, we're ready to train our model. I initialize a decision tree classifier from Sklearn with random state 42. Decision tree classification is a tree-based method that recursively splits the feature space into regions based on feature values, making decisions at each node to maximize information gain, and assigns the majority class to each leaf node. It's interpretable, but can overfit if not tuned. I call fit on xtrain and ytrain to train the model, allowing it to learn how features like THAL and CA distinguish between heart disease cases. I make predictions on xtest with predict, storing them in ypred, and evaluate with accuracy score and classification report. The results are solid. Accuracy score is 0.7833 to 78.33% correct predictions, or 47 out of 60 samples. The classification report details: for no heart disease, precision 0.87, recall 0.75, F1, score 0.81, support 36. For heart disease, precision 0.69, recall 0.83, F1, score 0.75, support 24. Macro average F1 score is 0.78. Weighted average 0.79. Decent performance, with better recall for heart disease cases. I use ShapTree from Interpret's Graybox module to explain our model's predictions locally. ShapTree is an explainability tool optimized for tree-based models, providing exact SHAP, Shapley additive explanations, values. SHAP values assign each feature a contribution to the prediction, based on game theory, by calculating the average marginal contribution of a feature across all possible combinations, ensuring fair attribution. I initialize ShapTree with our decision tree model, XTrain as the background data, and the feature names from XColumns. I generate a local explanation for the first test sample with explain local, extract the data, and print the results. Predicted 0, true value 0, correctly predicting no heart disease. Feature contributions show thal minus 0.1676, the largest negative contribution, pulling the prediction toward 0, likely due to a thal value of 6.0, indicating a lower risk. CA minus 0.1046 and OLPEAK minus 0.1066 also reduce the likelihood of heart disease, with CA 0.0, no major vessels, and OLPEAK 2.3 being less indicative of disease. Age minus 0.0697 and COL minus 0.0412 further lower the prediction, while THALIC 0.0230 slightly pushes toward heart disease, possibly due to a high maximum heart rate, a 150.0. Features like FBS and RESTEC at 0.0 have no impact. The visualization likely shows a bar chart with THAL's bar at minus 0.1676 in blue, pulling left, and THALIC's bar at 0.0230 in orange, pushing right, providing a clear breakdown of how features shape this prediction. Let's dive deeper into these outputs. They're a diagnostic goldmine. The first row showed a patient with age 63.0, sex 1.0, CP 1.0, COL 233.0, THALIC 150.0, CA 0.0, THAL 6.0, and target 0. No heart disease, while the next had age 67.0, CP 4.0, CA 3.0, and target 1. Heart disease present, suggesting higher CA and CP values increase risk. Accuracy of 0.7833 means 78.33% correct predictions, 47 out of 60 samples. The classification report confirms no heart disease has precision 0.87, recall 0.75, F1, score 0.81 for 36 samples. Heart disease has precision 0.69, recall 0.83, F1, score 0.75 for 24 samples. Better recall for heart disease, crucial for medical diagnosis. The local explanation predicted 0, true value 0, spot on. THAL's minus 0.1676 aligns with THAL 6.0, reducing risk, and CA's minus 0.1046 with CA 0.0 supports a lower likelihood of disease. OLPEAK minus 0.1066 with 2.3 is notable, as higher ST depression often indicates risk, but here it lowers the prediction, possibly due to other features. THALIC 0.0230 with 150.0 slightly increases risk, reflecting higher heart rates and stress. ShapTree's local explanation helps us understand this patient's diagnosis. To conclude this medical diagnostics journey, we've analyzed the heart disease dataset, 297 sample study, and trained a decision tree classifier, achieving an accuracy of 0.7833 and a macro F1 score of 0.78. The local explanation via ShapTree revealed THAL and CA as key drivers, providing transparency into our model's reasoning. Decision tree classification captured heart disease patterns, and ShapTree's exact SHAP values offered precise insights. Grab this code, experiment with tree parameters, and dive deeper into medical diagnostics. I'm inspired by this health analysis. Hope it's ignited your passion for data-driven medicine. Thank you for joining this course. See you in future data adventures.